Hello everyone, in this video we are going to see about the types of the graphs. So here we know that graph can be defined as group of vertices and edges that are used to connect these vertices. That means there are vertices and they are connected by the edges. A graph can be seen as a cyclic tree. So we know that tree is also a non-linear data structure where there are no cycles. But in the case of graph, we can have cycles. Cycles means closed loop or a closed area or closed part of the graph, where the vertices maintain any complex relationship among them instead of having the parent-child relationship. In the case of tree, the control flows from root to the leaves, that means the top to the bottom. But in the case of graph, there can be the connection between one node to any other node in the graph. Let us see few terminologies in the graph. Path. A path can be defined as a sequence of nodes that are followed in order to reach some terminal node V from the initial node U. That means we start from one vertex, which is U, and we travel along the nodes of the graph in order to reach some destination, that is called as a path. Simple path: if all the nodes of the graph are distinct, that means they are different, with an exception V0 is equal to Vn, then such path P is called as a closed simple path. A path that does not repeat the vertices is called a simple path. That means the vertices should not be visited again and again. So they will be visited only once. That is called as a simple path. Okay. Let us see with the diagram what is the definition or how the path looks like. So this is one of the graph. There are vertices and some vertices are colored, and this colored vertices have the edges in between them. Let us see. This is a path is given from 6, 8, 3, 1, 2 and 4. So here the path starts from this vertex 6, it goes to 8 and then goes to 3 and then goes to 1 and then to 2 and then to 4. They are given by the green color. So this is a simple path, okay, because there is no vertex is repeated. That means we do not, here we didn't visit the same vertex again. If you visit the same vertex again, that will become a loop or a closed path, okay. And even if we visit the same vertex multiple times, that will not be a simple path, okay. So definition is, we can see from this path there is no repetition of the vertex numbers, everything is different, okay. So the nodes are distinct, they are called as a simple path. And when we say it is a closed path, means V0 is equal to Vn. Suppose this particular path again comes and join to the vertex 6, which is the initial one. When 6 and 4 are connected in this diagram, that is called as a closed path, which is a simple path, okay. So here we got the definition for three different cases. One is the path with a sequence of vertices, and a simple path, there is no repetition of the vertexes, and then closed path when V0 is equal to Vn. That means the first node is equal to the last node. That is called as a closed simple path. It is also called as a cycle. Let us see a few more terminologies here. So let us see an example of a cycle or a closed path. A path will be called as a closed path if the initial node is same as the terminal node. A path will be closed if V0 is equal to Vn. Here we can see 1, 2, 3, 4. Okay, 1, 2, 4, 3 and then 1. Here this path shown in a green color is a closed path because there is the first one, the starting is the vertex 1 and end is also vertex 1, and it is also no repetition of any vertex. So it is a simple closed path, okay. So the path starts from 1, it goes to 2, then to 4 and then to 3 and then come back to 1. So here this forms a closed area. So this is called as a loop or a cycle, okay. And since there are no vertices repeated, this is also an example of simple closed path. The cycle, a cycle can be defined as the path which has no repeated edges or vertices except the first and the last vertices. And some terminologies, few more terminologies about the connected graph. What is the connected graph is? A connected graph is the one in which the path exists between every two vertices u comma b in V. From every vertex to any other vertex, there should be some path to traverse. There are no isolated nodes in the connected graph. You can see in this particular graph, A, B, C, D, E are the vertices, and all the vertices are connected to one another using the edges. So no vertex is left alone. So this is called as a connected graph. Now let us see the another example of a graph which is disconnected graph. Here we are having ABC is one portion or one section and DEF is another section. This is totally one graph, but they are disconnected. This is so here there is no path exists from B to D or C to E or from A to F. So this type of graph where the vertices are disconnected, that means there are no edges between all the vertices. This is called as a disconnected graph. And then some few more terminologies about what is a complete graph. What is a complete graph is, a complete graph is the one in which every node is connected with all other nodes. Here you can see they are called as with the symbol K. Complete graph is given by the symbol K. So K2, K3, K4, this means the number of vertices in the graph. There are two vertices is called as K2. Here there are three vertices is called as K3. Here there are four vertices, 1, 2, 3 and 4 is called as K4. So the number of vertices gives the number of the complete graph. So let us see what is the formula by which the number of nodes are connected by the edges. So a complete graph contains n into n minus 1 by 2 edges, where n is the number of nodes in the graph. Okay, so here when you say, for example, the number of vertices are 2, 3, 4, 5, 6 and 7. The nodes will be 1, the edges will be 1, 3, 6, 10, 15 and 20. If you apply this formula n into n minus 1 by 2, we will get to the respective number of edges with the respective number of vertices in the graph. That means here the connection happens between one node to every other node. So this is called as a complete graph. These graphs also represent the communication network between the different terminals in the computers. And next is the weighted graph. What is the weighted graph is, along with the edges some values are attached. They are called as a weight. For example, if you travel from a place A to B and it requires 2 hours or 2 units of time or 2 units of amount to travel, whatever the values may be, the weight shows some unit of measurement that happens between one vertex to the other vertex. So it is called as a weighted graph. The definition is, in a weighted graph, each edge is assigned with some data such as length or weight or time. Any other unit can be attached. The weight of an edge can be given as W of E, which must be a positive number value indicating the cost of traversing the edges. The weighted graph can also be applied in both directed and undirected graphs. So that's all definition. Hope it is easy to follow, and thanks for watching.